This is section 3.3, linear equations in two variables. We are still dealing with equations that have both an x and a y, and all of this is still related to graphing. What we're going to be focusing on more in this section is creating equations based off little bits of information that we are given. Now, we need several formulas in order to get this done. The first formula is the one we learned in the last section, but we didn't go into that much detail about. It's y equals mx plus b. It is called slope-intercept form. You really do want to learn the name along with the formula. M is your slope, 0b is the y-intercept. We sometimes get to plug into this formula, but more often we're going to be rewriting equations so that they fit this form. This is the format that you need to rearrange things in order to be able to enter them in a graphing calculator. It's pretty important. Okay, then we have the point-slope formula. This tells you exactly what you need in order to be able to use it. You need a slope, and you need a given point. The formula is y minus y1 is equal to m times x minus x1. Your m is your slope, it goes right here. x1 goes here, y1 goes here. Regular x and regular y are part of your answer. That's what messed me up so much when I was first learning this. I wanted to plug in everywhere, but regular x and regular y are part of your solution, just like x and y are still okay here. This is almost always your first step. We're going to be plugging into this formula, but we're never going to leave anything in this form. You'll be asked usually to plug into this and then either rewrite it in slope-intercept form, which is up here, or standard form, which we're about to talk about. Okay, now standard form. ax plus by is equal to c. We do not plug into this formula whatsoever. All we will be doing is occasionally rewriting something so that it is in standard form. Standard form is very picky. The variables must be in this order. It must be the x, and then the y, and then equal to the constant. A, B, and C, those are just numbers. Whatever they end up being is what they are. But the first number needs to be positive. If, as we rearrange things, that first number is negative, then we need to multiply the entire equation by a -1 in order to make that positive. We're also not allowed to have any fractions. We must kill any fractions that appear. Equations must be quote-unquote reduced. I don't have a better word for this. So what I mean by that is, let's say we had 4x minus 18y equals 6. I don't have fractions. They're in the right order. The first number is positive, but this is not in standard form because each of these numbers can be divided by 2. It really is like reducing a fraction. If I can divide all of these by a 2, I must do that. So that would be 2x minus 9y is equal to 3. This would be the standard form of that particular equation. And like I said, you're never going to plug in here. This will only be used if you are asked to write something in this format. Now what I've done is I've written all our formulas on an index card so that we can refer to them easily after this. Okay, so first types of problems. Write the equation of the line that meets these conditions. Give answer in slope-intercept form. You really need to pay attention to this, so I'm going to get it in y equals mx plus b form. Okay. Now, on this problem, we are given a slope and we are given a point. Since we are given a point and we are given a slope, we can use point-slope formula. And I can work it this way. Now, if you happen to notice and they tell you that this is your y-intercept, then you're not just given any point, you're given a special point. And since slope-intercept form, the b is from the y-intercept, this must be your b value. We have our slope, we have our y-intercept, we can go directly into this format. Y is equal to m, negative 2/3, x, plus b, 4/5. And that's the answer they're looking for. Okay. So let's say, again, that we have a slope of -3/4, and we are given the y-intercept 0, 7. Again, since the point we are given happens to be the y-intercept, that is our b value. So this answer would be y equals m, -3/4 x plus b, which is 7. Okay, now this one I'm going to work the other way as well, just to show you that it works. I'm going to plug into the point slope formula and then we'll rearrange some things. Okay, so it's y minus y1. This would be my y1 and this would be my x1. Okay, so separate. Y minus y1, which is 7, is equal to the slope, -3/4, times x minus x1. x1 is 0. Okay, well, x minus 0 is just 0, so I get y minus 7 equals -3/4 x. And now we're asked to write it in slope-intercept form, which means I need the y by itself. So if I add 7 to both sides, I get y is equal to -3/4 x plus 7, which is exactly the same thing. So if you don't happen to recognize that the point they've given you is a y-intercept, it works. If you happen to recognize it, it's quicker. You don't get this very often, though. Okay. Write the equation of the line with the given slope that passes through the given point. Write answers in standard form if possible. Okay, so the point we are given this time is not an intercept, so we don't really have a choice. This is our x1, this is our y1, and we're going to plug it into the formula. The formula is y minus y1, so y minus 6 is equal to the slope, which is -5/6, times x minus x1. x1 is -1, so be careful with your signs here. So this is really y minus 6 is equal to -5/6 times x plus 1. Minus a -1 is plus 1. Okay, so we have an equation here. It's just not in standard form yet. So there are a couple of ways you can work this. I can distribute the -5/6 and then rearrange things. One of the things, though, is that we are not allowed to have a fraction. So we can go ahead and kill the fraction here. If I multiply both sides by this denominator, so I'm going to multiply all of this by a 6 and multiply this by a 6 as well, then it should make my fraction go away and make the rest of it easier. Now, if I multiply this by a 6, I'm going to need to distribute. This is 6/1 times -5/6 times x plus 1. This is 3 things multiplied together. It's just that last one's a little bit more complex. So what happens here is that that 6 cancels with that 6. And what I end up with is, I'm going to distribute, but just to make it clear, that 6 canceled with that one, so now I need to distribute the -5 that is left over here. Okay, so let's go ahead and distribute on both of these. And I'm going to move up here. That gives me 6y minus 36 is equal to -5x minus 5. Now, if we look at the index card, we don't have fractions. The first number must be positive and it has to be in the correct order. Let's just go ahead and get things in the correct order. I need my x to be absolutely first. So that means I'm going to move this all the way over to here, and I do that by adding 5x to both sides. So I have 5x plus 6y minus 36 is equal to -5. Okay, so I need the x and then the y, and it needs to equal the constant, so that means I need to move the 36 over to here. So if I add 36 to both sides, 5x plus 6y is equal to, that's going to be 31. Okay, so let's see if we are in standard form now. X and then y equals constant. It's in that order. I don't have fractions. First number is positive, and there's nothing that divides evenly into 5, 6, and 31. So this would be your answer in standard form.